Okay, let's unpack this. We're diving deep today into something that's quietly essential. A foundational component in countless industries that you might not think about every day. The global ceramic tube market.
That's absolutely right. And when we talk ceramic tubes, we're often talking about these high-performance parts,
Mm.
really crucial for demanding industrial and, well, electrical applications too.
Right, like what specifically?
Think everything from elements in, say, high-temperature furnaces to protective sheaths for sensitive sensors, maybe in critical machinery. They're small components, but they enable a lot of bigger things to happen.
Got it, exactly. And our source for this deep dive is one comprehensive market report. It looks at the landscape from 2021 all the way out to projections for 2033.
Right.
So our mission today is really to crack open this report, pull out the most important numbers, understand the major trends, and figure out the current state and, I guess, the future trajectory of this really vital market.
Okay, so what's the big headline from the report? What's the takeaway?
Well, overall, it paints a picture of pretty healthy and steady growth projected globally for ceramic tubes, over the next decade or so.
Okay, healthy and steady. Let's put some numbers on that. What are the big global figures the source gives us?
Okay, so back in 2021, the worldwide market was valued at just over $1.4 billion, specifically 1,415.92 million.
Right, 1.4 billion, and the report sees that climbing. Where does it go by 2025?
It hits around $1.74 billion by 2025,
Okay.
and then makes a pretty significant jump, actually, to over $2.64 billion by 2033. So 2,641.27 million.
Wow, okay. That trajectory then, it translates into a global compound annual growth rate, a CAGR, of approximately 5.3%. 5.333% to be exact over that period.
And 5.3% year on year, that's pretty solid, isn't it, for a fundamental component market like this?
Oh, definitely. Pretty solid indeed. So the report's overall conclusion is definitely one of, healthy, steady expansion with promising opportunities worldwide.
So the next question is, where is that growth actually happening? Let's zoom in a bit and look at the landscape region by region, because this is where you see some really interesting differences.
Yeah, absolutely. And what immediately jumps out in this source is Asia Pacific, APAC. The report clearly presents it as the current market leader and the fastest growing region globally.
Oh, it really is, isn't it? Back in 2021, APAC's market was already substantial at over $504 million. $504.069 million. And by 2033, it's projected to almost double. Hits over $993 million. $993.118 million.
Almost $1 billion just in APAC. That kind of rapid expansion gives APAC a CAGR of nearly 6%, 5.981% precisely.
And that's noticeably faster than the global average we just talked about.
Yeah, it's the most rapid regional growth rate highlighted in the report, actually.
And when we look inside APAC, the source points to a couple of major drivers, right?
Definitely. China, for instance, huge part of that market, just under $185 million and $184.993 million in 2021.
Okay.
And expected to soar to over $393 million by 2033. $393.275 million.
Wow. And it's AVR.
That's the highest among the specifically named countries in the report, 6.564%.
Over 6.5%. Okay. And India.
India's right there with China, showing similarly strong growth. They went from around $87 million, $86.9012 million in 2021, to a projected $184 million, $184.124 million by 2033.
Okay.
With a KGR of nearly 6.5% as well, 6.492%.
So this kind of explosive growth in China and India, it really suggests a major expansion, doesn't it?
Yeah.
And things like heavy industries, electronics, manufacturing, infrastructure sectors, the kind that rely heavily on these high-performance ceramic tubes.
Exactly. That's likely what's driving it. The report also lists other significant contributors in APAC, like Japan, South Korea, Australia, Singapore, indicates steady performance there.
Right.
And it specifically calls out Southeast Asia, projecting that to reach over $144 million by 2033. And Taiwan, just under $29 million by 2033, with a 5.1% CAGR.
So yeah, APAC is definitely the engine room, kind of powering a lot of this global growth.
No doubt about it. Okay, so moving across the globe. North America. The report presents it as the second largest regional market back in 2021.
Yep. Their value was just over $406 million then. $406.37 million.
Okay.
The report sees it climbing to about $483 million, $482.81 million by 2025. And then over $707 million, $707.861 million by 2033.
Okay, so what's the growth rate there, the CAGR for North America?
It comes in at just under 4.9%, 4.899%. Still solid, but, a bit slower than APAC.
Right, makes sense. And within North America, I assume the U.S. is the big player.
Predictably, yes. The U.S. market was over $309 million, $309.166 million in 2021.
Yep.
Projected to reach over $532 million, $532.16 million by 2033.
And it's CAGR.
4.8%. 4.812%. So this steady growth likely reflects, the continued strong demand for those established industrial and high-tech sectors that use ceramic tubes in the U.S.
Yeah, the established base. But what's interesting here, looking at the numbers, is Canada and Mexico, they start from smaller bases, right? Canada around $51 million, Mexico $46 million in 2021.
Right. $50.9588 million for Canada, $46.2449 million for Mexico.
But they're projected to have slightly higher CGRs than the U.S. by 2033. Canada's is over 5.3%, 5.305%.
Oh, interesting.
And Mexico is over 5%, 5.012%.
Huh. So that suggests maybe slightly faster adoption or perhaps expansion in specific industries within those countries compared to the overall much larger U.S. market.
Could be. It's an interesting nuance. Okay, let's turn to Europe. That represents the next significant chunk of the market. Value is around $345 million, $345.485 million in 2021.
Right. And that's expected to grow to about $415 million, $414.834 million, 2025, and over $620 million, $620.699 million by 2033.
And who are the key players in Europe, according to the report?
Well, Germany stands out. It has the highest projected CGR among the specific European countries listed at nearly 5.6% to 5.587%.
Okay.
It grows from about $62 million, $62.1873 million in 2021 for over $118 million to $118.553 million by 2033.
That strong growth in Germany, that could point to, well, resilience and innovation in its industrial base, couldn't it?
Yeah, absolutely. The UK also shows pretty robust growth, over 5.4% CAGR. That's from around $28 million to $52 million.
Yeah.
27.9843 meters to 52.449 meters.
Okay.
France is mentioned too, with a KGR of just over 4.1%, growing from about $33 million to nearly $53 million. 32.8211 meters to 52.7594 meters.
All right. Any others mentioned?
Yeah, this source also includes Italy, around 13.88 meters in 21. Russia, about $48.07 meters in 21. Spain, around $22.05 meters in 21. Sweden, Denmark, Switzerland, Luxembourg.
Yeah.
It says they're all contributors showing solid growth.
Okay. And then there's this interesting bit, the rest of Europe.
Yes. This subregion actually has a notably high CAGR, over 5.8%, 5.801%.
Wow.
It's projected to more than double from about $86 million, 86.0258 meters in 2021, to over $171 million, 171.62 meters by 2033.
That's quite high. It suggests, well, significant, maybe diverse industrial or technological development happening in aggregate across those other European nations.
Exactly. Maybe smaller countries, but growing fast in certain niches.
Okay.
Shifting now to South America, the market there was around $62 million, $62.3006 million in 2021.
Okay. And projections?
Projected to reach approximately $99 million, $99.351 million in 2025, and over $153 million, $153.194 million by 2033.
So what's the growth rate look like there?
The KGR is nearly 5.6%, 5.562% to be exact.
Okay, so while the absolute value is smaller than, say, Europe or North America, that CAGR is actually relatively high.
Yeah.
Faster than both of them.
Yeah, it is. And Brazil leads the way there. Started at about $20.6 million, 20.6464 meters in 2021, projected to reach nearly $52 million, 51.9994 meters by 2033.
And it's a TGR.
Over 5.7%, 5.758%.
And the report mentions others, too.
It does. It notes that Argentina, Colombia, Peru, Chile, and the rest of South America are also seeing solid KGR figures, somewhere between 4.7% and 5.7 troops.
So that growth in South America, it could be linked to maybe expanding industrial sectors, infrastructure development, things that utilize ceramic tubes.
Seems likely. Okay, now the Middle East. This presents a bit of a different picture in the report.
How so?
Well, the market value was about $59.5 million, 59.4688 meters in 2021, projected to reach about $71.5 million, 71.463 meters in 2025, and just over $95 million, 95.0858 meters by 2033.
Okay, and the growth rate?
Their regional CGR is most moderate mentioned anywhere in the report, actually, around 3.6%, 3.634%.
Ah, okay. Slower growth overall then. Who's the leader there?
Saudi Arabia is the largest market, going from around $25.5 million, 25.502 meters in 2021, to nearly $39.8 million, 39.7649 meters by 2033.
Right.
And other countries like Turkey, UAE, Egypt, Qatar are noted as contributing steadily, but their TGRs are, in that 3.1% to 3.9% range.
So that moderate growth, it might just reflect a different pace or maybe a different scale of the specific industrial applications that use ceramic tubes in those areas compared to, say, APAC.
Could be, but here's where it gets really interesting and a bit of an outlier according to the source.
Oh,
The report points out that the rest of the Middle East subregion, it displays the highest projected CGR mentioned anywhere in the entire source,
get out. How high?
a staggering 7.294%.
Wow, nearly 7.3%. Now, okay, it's probably starting from a very small base.
Exactly. It's starting from a tiny base, around $2.8 million,
Mhm.
2.795 meters in 2021, growing to about $5 million, 5.0205 meters by 2033.
Okay, so small numbers overall, but that rate is exceptional. It could signal some really targeted investment or maybe rapid development in specific high-tech or heavy industrial niches within those smaller Middle Eastern countries.
That's what it suggests, yeah. Very intriguing. Okay, finally, let's look at Africa.
All right, what does the report show for Africa?
Market size, just over $38 million, 38.2299 meters in 2021, projected to reach over $71 million, 71.3143 meters by 2033.
And the CGR?
About 4.4%, 4.396%.
Okay. Any specific countries highlighted?
Nigeria is specifically mentioned, growing from around $9.4 million, 9.4046 meters, to nearly $18 million, 17.971 meters by 2033, with a CGR of 4.6%. And South Africa and the rest of Africa are also noted as performing steadily at over 4.2% annually.
Okay, so consistent growth in the African industrial sector where these tubes are used, albeit maybe slower than APAC for sure.
Definitely. So, okay, if we try and synthesize all these numbers, all these trends,
Yeah.
the big picture really is one of steady global growth for ceramic tubes, right?
Yeah, absolutely. And it's largely powered by that rapid expansion we saw in Asia Pacific, particularly China and India. Seems closely tied to their booming manufacturing and industrial sectors.
Right. But while APAC is the clear leader, the report shows these, significant growth pockets and quite different growth profiles across the globe.
Exactly. You've got North America and Europe showing solid, consistent growth, probably reflecting stable demand in their established industrial bases.
Yeah.
Then South America showing relatively high growth from a smaller base, perhaps, as we said, tied to infrastructure.
And then you have these really fascinating outliers, like the rest of Europe and especially that rest of the Middle East, showing surprising speed, even if from smaller starting points. Kind of hints at targeted or emerging industrial activity.
Yeah, lots of nuances.
Okay, so what did this all mean for you, our listener?
Well, understanding the dynamics of a market like ceramic tubes, seeing where the demand is increasing globally for these sort of fundamental industrial and electrical components, it gives you a really valuable window, doesn't it, into broader shifts in global manufacturing, technological adoption, industrial investment. It shows you where those essential building blocks are seeing increased use.
It definitely connects the dots between a specific, maybe overlooked component and that wider industrial landscape.
So here's a final, maybe provocative thought for you to take away from this deep dive. This report, it's excellent at showing us where the growth in demand for ceramic tubes is happening, places like China, India, Germany, and those high STR smaller segments like rest of the Middle East.
Right, the what and where, exactly. But while it mentions the applications, industrial and electrical, it doesn't explicitly detail which specific industrial or technological advancements, or maybe which manufacturing booms in these high-growth areas are uniquely driving that demand faster than elsewhere.
Yeah. The why behind the numbers.
Precisely. What new factories, what specific energy projects, what advanced electronics production lines, or what sensor technologies are flourishing in these particular regions that require ever more ceramic tubes? That's a question, worth pondering as you keep an eye on global economic and technological news. Okay, let's get started. Welcome, everyone, to this deep dive. Today, we're digging into a really specific but vital area, the ceramic tube market.
That's right. And we're using insights mainly from cognitive market research to sort of unpack this.
And these aren't just any tubes. We're talking about components critical in, some seriously high-performance situations.
Exactly. Think aerospace, energy sector, advanced electronics, even medical devices. Places where, the usual materials just won't hold up. Ceramic tubes are designed for those extremes.
Right. So let's explore what's really driving the demand here. What are the main forces pushing this market forward, based on the research?
Well, the big one, fundamentally, is the growing need for advanced ceramics in general. Industries are turning to them more and more.
Okay, but why? What makes them so special?
It really comes down to their properties. Things like amazing resistance to corrosion,
Yeah.
and they handle extreme environments, super high temperatures, without much thermal expansion at all.
Ah, that minimal thermal expansion, that sounds incredibly important. I mean, especially for things like jet engines or power plants where temperatures go way up and down.
Precisely. If parts expand or shrink too much, things fail. Ceramics stay stable. That means better reliability, less maintenance, costs less in the long run compared to metals that might warp or degrade.
So they keep their integrity where metals might fail. Makes sense.
Yeah, and the source also mentions that new developments in material science, like nanotechnology, are constantly opening up new potential uses too. It's not standing still.
Okay, the performance benefits are clear. But, like anything, there must be hurdles. What's holding the market back? What are the restraints?
The number one issue, cost. Plain and simple, they're expensive to make.
How so? What drives up that cost?
It's a few things. The manufacturing process itself is very energy hungry. You need incredibly high temperatures for firing, for sintering, basically fusing the ceramic powder together. That takes a lot of power.
Okay, high energy use.
And the raw materials aren't cheap either. We're talking high purity stuff like alumina, zirconia, silicon carbide. Much pricier than, say, standard steel or polymers.
Right, so materials and manufacturing are both costly. And what about working with them? I've always heard ceramics are, well, brittle.
They definitely can be. That's a second big challenge. Ceramics generally have low fracture toughness. They don't bend, they just break. If they're put under the wrong kind of stress, they can fail suddenly.
So handling and installation must be tricky.
And machining them, too. Shaping them into precise tubes is tough. You need special diamond tools because ceramics are so hard. It's slow, it's labor intensive. All that adds to the final cost and complexity, you know? It can make some potential users hesitate.
So, amazing performance, but high cost and tricky to handle. It's a trade-off.
A classic engineering trade-off, really.
Yet, despite these challenges, the market is moving forward. What are some of the key trends shaping its future?
One really exciting trend is additive manufacturing. 3D printing, but for ceramics.
3D printing ceramics. How does that change things?
It's potentially revolutionary. It lets you create really complex shapes. Think intricate internal channels, custom designs that would be incredibly difficult or just impossible with traditional methods like molding or extrusion.
Wow, okay. That opens up a lot of doors, like
Mhm.
maybe custom medical implants or super compact microreactors, specialized electronics parts.
Exactly those kinds of things. It unlocks new design possibilities. Another big trend, kind of related, is miniaturization.
Miniaturization, so smaller and smaller parts.
Yeah, driven by electronics and healthcare especially. Devices are shrinking, becoming more sophisticated, and that means there's a rising demand for microceramic tubes. Tiny little tubes.
Microceramic tubes. What are they used for at that scale?
Things like precision insulators in tiny circuits, components in very small sensors, or even parts for endoscopic tools used in surgery. Places where you need high performance in a really tight space.
And their properties, like thermal conductivity or electrical insulation, are still valuable, even when they're tiny.
Absolutely. And biocompatibility is key for the medical uses too. They offer those benefits in packages that are getting smaller all the time.
So it really paints a picture, doesn't it? Whether you're, say, an engineer thinking about next-gen designs, or maybe an investor looking at material trends, or just someone interested in tech. This evolution of ceramic tubes is fascinating. You see the push from extreme needs, the pullback from cost and complexity, and then these new trends like 3D printing and miniaturization pushing things forward again.
It really underscores how vital material science is. It enables innovation everywhere.
So just to recap quickly,
Yeah.
we've touched on the drivers like performance under pressure, restraints, mainly cost and brittleness, and these emerging trends, additive manufacturing and going micro.
Yeah, it's a market defined by these unique capabilities facing off against some pretty significant challenges.
Which leaves us with a final thought. Given those amazing properties, but also the real barrier of cost and handling, how might future breakthroughs actually bridge that gap, make them cheaper or easier to work with? And thinking beyond the current uses, what completely new fields could ceramic tubes disrupt next? Something for you to ponder.